Let's explore how metals react with acids. And for that, let's start with an experiment. We're going to take dilute hydrochloric acid and add zinc to it. And let's see what's going to happen. So we're going to add zinc. And look, the moment we add the zinc capsule, we start seeing bubbles. What is this? Why did this happen? Okay, now let's do another experiment. This time, we're going to add magnesium to the same dilute hydrochloric acid. And let's see what's going to happen. We again see bubbles. But wait, this time the reaction looks much more vigorous than before. If you compare the two, this is with the zinc, this is with the magnesium, you can clearly see there's more vigorous reaction over here. So what is it going on? What does it mean? So what happens when zinc reacts with hydrochloric acid? Well, since zinc is more reactive than hydrogen, it kicks it out and forms zinc chloride. And so the hydrogen comes out. And so the bubbles that you saw was actually the hydrogen that was coming out. Now this reaction is not balanced. So to balance it, we just have to put 2 over here, and there we go. Similarly, what happened when magnesium reacted with HCl? We got something very similar. Magnesium is again more reactive than hydrogen, so it kicks it out. And you get magnesium chloride, and again the hydrogen got liberated. So in general, when you have metals reacting with acids, what do we get? Well, metals react with dilute acids in general to give you salt and hydrogen gas. So these are the salts, and this is the hydrogen gas that is evolved. Now the last thing to remember though is that chemistry always has exceptions. For example, you might think that copper will also react with dilute hydrochloric acid to give you the same reaction, copper chloride plus hydrogen gas. But guess what? That doesn't happen. Copper does not react with hydrochloric acid. The reason is that copper is less reactive than hydrogen, and therefore copper is unable to kick the hydrogen out of its place. Now you might be thinking, well, how do I remember which is more reactive and which is less reactive? We will learn more about reactivity series in a future video. But the point is to remember that this is there are exceptions to it. Another example of another exception is for the acid, if you take nitric acid, which is HNO3, then we find out that in most cases, again, it does not give you hydrogen gas when it reacts with a metal. Why is that? Well, because if a metal kicks the hydrogen out, then nitric acid is an excellent oxidizing agent, which means it can provide oxygen to that hydrogen that is kicked out, and that hydrogen combines with the oxygen to form water. So you don't get hydrogen gas in most of the cases. So sure, in general, we can say that metal plus acid gives you salt and hydrogen gas, sure, but remember, it's chemistry, so there will always be some or the other exceptions.